Good morning. In the past class, we have seen the DC motors and its construction and its working principle. Now we are going to see the same thing, which is to be in a dealing with AC supply. The motor in which we are giving a DC supply, then we are saying that is a DC machine and DC motor. We are giving AC supply and we are running the motor, that is called as a AC motor. For induction, now we are going to see the AC motor, which may be in the AC motor, it is of two types. We may say synchronous machine and asynchronous machine. In AC also generator and motor is there. Synchronous and asynchronous is there. Synchronous machine is that it will be of continuously running in a constant speed. Now we are going to see the asynchronous motor, which is of two types. One is induction, which is of induction motor, and other types of motors are all there. In induction motor, if we are using it for a single phase supply, then it is called single phase induction motor. When we are supplying with a three phase supply, it is called as a three phase induction motor. In your syllabus, it is for single phase induction motor. There are different types of single phase induction motors available because of its construction features. It is getting varied. So in the single phase induction motor, what is the thing is that we have been using it in a domestic appliances also. Wherever we go, we may see single phase. In your home pumping systems, you will be using single phase induction motors. Even in swing machines, they are using single phase induction motor. Hair dryers, all other things, we are using a single phase induction motor. Single phase induction motor is that it is similar to that of the constructions of the three phase motors also. Three phase motors and single phase motor have same type of construction. In induction, single phase induction motor construction is also same as that. It has stationary part and rotational part. Stationary part is called as stator and rotational part is called as rotor. The same as that of DC machine. But what is the change in stator and rotor is that your stator is like a skewed bar. It will be like a rod, which is of squirrel cage type of rotor. How it will be there, a slots will be connected. Stampings, that is steel thing, will be stamped in a round manner. There will be no winding in the rotational part. This is the rotational part, and here the rotational part is like a electromagnet, and your stationary part is a winding. Your single phase winding will be available in the stator. So rotational part is a skewed bar, which will be of steel stampings collected together in a round manner. If you insert this in the stationary winding and you supply a single phase supply to the stationary part, your rotor will start rotating. So your single phase induction motor works on the principle of double revolving theory. The same principle, it works based on the concept of electromagnetic induction, but the working principle is under the concept of double revolving theory. That is, a stationary flux and rotating two flux will be generated, and the two flux should overcome each other. If it is of equal your rotor will be locked. That is, your torque generated will be less to rotate the rotor. So to overcome that, you have to add an additional winding. That's why your single phase induction motor is not a self-starting motor. You need an additional method to start the single phase induction motor. So if it is of three phase induction motor, it is a self-starting motor, but in single phase it is not a self-starting motor, because magnetic flux generated in the rotor and the flux generated in the stationary part will be of equal, and because of this, your two flux will be of equal, it will get nullified, and the torque generated will be of net torque will be of 0, so the rotor will not able to rotate. So in order to avoid that, we are adding a temporary winding in the single phase induction motor. That temporary winding, what it is doing is that it will create a flux which is not nullified. That will also create a flux during the starting period. That will create a more flux, and because of that, torque will be generated, net torque will not be equal to 0, and your motor will be start rotating. So there are different types of single phase induction motors are there. The first one is a split phase induction motor, second one is capacitor start induction motor, capacitor start, capacitor run induction motor, and shaded pole motor. So first we will see the split phase induction motor. Split phase induction motor is nothing but we will be having a, as I said, two winding will be there. One is temporary winding, that is called as auxiliary winding, and second one is main winding, which is called which is the winding of the stator. This is the main winding and this is the auxiliary winding. This is how we will represent the induction motor's equivalent circuit in equivalent circuit manner. We are supplying a single phase supply to the motor. When at the starting what happens is that because of the this in the main winding, the centrifugal switch will be present. This switch is nothing but maybe a relay or a centrifugal switch, in which if it is having, when the supply voltage is given, when the torque is less compared to the rotor, this switch will be in closed condition. So the current will be flowing in the auxiliary winding. Once this torque will also generate, so this circuit is closed, so the flux will be generated in this and this also. So this generated flux will be able to rotate the rotor, and the rotor will rotate. Once 70% of torque is achieved, that is speed is achieved in the motor, your auxiliary winding will be disconnected. That is, the torque will, if it is higher than this rotor to rotate it, your centrifugal switch will open and the auxiliary winding will disconnected when it achieves 70% of load torque. So this is how we are split phase winding works. That is, if we are using a single phase induction, we are making it to two phase supply at the starting. We are making another phase by adding auxiliary winding and then disconnecting the second phase, and we are running it within a single phase. So we are splitting up the phase. So this motor is named as split phase induction motor. The same thing for next is the capacitor start motor. In the capacitor start motor, what will be the additional thing present is the capacitor. In the auxiliary side of the winding, we will be having a capacitor which improves the power factor, which improves the power supply condition of the motor. The same thing, when your torque is not achieved, at the starting your torque will not be achieved, your centrifugal switch will be closed, your capacitor will be there which improves which acts as a second phase, and your auxiliary winding improves the flux generation, and the net torque is not, now it is not equal to 0, and your capacitor improves the power factor which is in a leading manner, and your rotor will start rotating in the anti-clockwise direction. So blocked rotor is of rotating nature now. Once 70% of speed is achieved, your capacitor connected auxiliary winding will be disconnected. So this thing is considered as the capacitor is added at the starting period. Once the torque is achieved, your capacitor will be disconnected with the help of centrifugal switch. So this motor is stated as capacitor start motor. Then next is the two value capacitor motor, that is capacitor start and capacitor run motor. We will say that as a capacitor start, capacitor run, or two value capacitor motor. In this also, once the switch is once the torque is not achieved, net torque is equal to 0, your centrifugal switch is closed and the current flow will be in both the resistance. So this motor is always running in two phase. So capacitor start, capacitor run motor is of two phase motor. It always runs in, we can say this as a two phase motor. It always runs in a two phase. Once if net torque is 0, the current will be starting flowing in the auxiliary winding, and once the 70% of torque is achieved, even this is disconnected, but additional capacitance present for running the motor, that capacitance will because once in capacitor start motor, the capacitor is connected at the starting stage and is disconnected. In the starting stage, it improves the power factor and improves the performance of the motor. In order to achieve the performance continuously, we have to keep the capacitance in the circuit till the end period of the motor, till we are turning off the motor. For that, we are adding a additional capacitance which is connected in the flow of main winding and auxiliary winding. In that, if the centrifugal switch is even open, the additional capacitance present in the motor will makes the power factor and performance of the motor to improve. So this is what this is why it runs always in a two phase. Additional phase is given by the additional capacitance added to the motor. So this motor is given. Then again, a permanent split capacitor motor is there. In the permanent split capacitor motor, the auxiliary winding will be connected continuously till the end of the motor. That is, there will be no centrifugal switch, and because of that, your motor performance is also increased. The final thing is the shaded pole motor. The shaded pole motor is having a two stator poles. Here I have taken an example of shaded pole motor with two stator poles. Two stator poles is nothing but it is similar to the construction of DC machine, in which magnet will be present. Two shaded poles, 1, 2. Two shaded poles are there, and rotor is of squirrel cage rotor. As I said, it is a skewed bar. It is of a bar, cylindrical bar made of steel, irons, etc. So this will be interlocked like this. It will be connected. If it is like this, it will be connected. It will be connected in a cross manner with the help of end rings, with the stampings. The stampings will be connected in the help of end rings. Here in the motor, a stator winding is wound. This stator winding and rotor is of, when you supply we may call this shaded pole motor as AC series motor. When you supply single phase supply, phase neutral, to the winding wound on the stator, a flux will be generated in this. Because of this flux generated interacts with the magnetic material, ferromagnetic material, that will also create a flux. Because when this flux is greater than this flux, when the flux generated by the rotor is greater than the flux generated by the stator, a torque will be generated, that is opposing force is generated, so that this rotor will start rotating. So this is how a shaded pole motor works. If it is common in the construction that a rotor will be of squirrel cage rotor, there will be no winding in it. It is made of steel stampings. For providing insulation, there will be a laminations will be provided in between each stampings. This is the construction of rotor. The stator part, a magnet will be present, in that a field winding will be wound. The outermost frame is of yoke. Those things are common. But in AC series motor and single phase induction motor, there will be no brushes and commutators will be present, because in AC series motor everything we are supplying directly AC loads, AC supply to the motor. So there will be no need of converting the AC to DC or a DC to AC for regulating the supply. We don't want commutator. And another thing, brushes. So brushes is also not necessary in the single phase induction motor for collecting the power. Here it is of alternating power, so we don't want to collect the power and transfer it. So from this we infer that single phase induction motor is not self-starting motor, and it is of starting with an addition. If you provide an additional winding, it will run in a normal condition. So why we need to study the single phase induction motor? What are all its application? See, single phase induction motor is used in our day-to-day life for pumping, I said. Then again, in ceiling fans, a split phase induction motor is used. If once the capacitor in the, for example, we have seen a lot of problems while rectifying the fan. They will say a coil will be blown off in the fan. For it is a normal thing everyone would have come across. What is the coil in the sense is that your capacitor present in the split phase induction motor will be blown out. That is, it is damaged, it is spoiled. So because of that, your fan will be rotating very slow, or excitation will take slow. Sometimes your fan will not rotate, it will only give a sound, vibrational sound. So why it happens is that your capacitor start condition is not achieved in that, so torque will not be achieved. This is the simple example I am giving for the single phase induction motor of split phase type. So your next topic is servo motors. So servo motors is nothing but a control mechanism which is adapted to the simple DC motor and AC motor. Servo motor is, as I said, servo mechanism. Controlling the motor with the help of servo mechanism. So generally in normal DC motor or normal AC motor, if you add a servo mechanism, then it is called as a DC servo motor and AC servo motor. So servo mechanism is nothing but you are giving a particular input and limiting that input to operate the motor within the given limit of input. So your control will be of how we are giving an input that should be displayed at the output. So that is called as a servo control. So this servo control is employed in motor for the speed control of the motors or achieving the certain speed of the motor. So for controlling the motor, servo control we are employing with the help of a position sensors present in the rotor. For controlling the speed of the motor, we need to know the position of the, we need to sense the speed. How the speed will be sensed? Your position of the rotor, angle of position of the rotor must be sensed by the sensor that will be given as a feedback to the motor, to the comparator, and your input will be compared with the given output from the sensor, and that will be compared and gives the error signal, and your controller or error amplifier will rectify that, and from that the voltage supplied to the motor is altered. So that is how your DC servo motor and AC servo motor works. So DC servo motor, what will be the construction of DC servo motor? There will be no internal change in the construction of the DC motor, but we are adding a servo control drive. In that we will add an encoder from which the sensor data will be given to the amplifier circuit. From the amplifier, the voltage needed to be supplied to the motor is given to the motor. So additional encoder and amplifier circuit will be present on the yoke of the motor. So let us see, this is a DC servo motor. In this they have given us a disassembled way. This is encoder which will be present at the, if it is a motor like this, it is there, it will be present here. The encoder will be present in this manner. So encoder, tacho generator. Tacho generator is nothing but, tacho means speed. It senses the speed. From the speed sensor, encoder gives the data to the error amplifier and that will be rectified. So these parameters, stator, rotor, brushes, from that you will be having a gear. So this will convert the gearbox mechanism, this will convert the speed into, that will be connected to the generator, that this speed is given to the tacho generator with the help of this brake control part. So this is how your DC servo motor will be there. There will be no any construction changes. In addition to that, it will be added with the encoder and tacho generator. So how does it work? A servo motor, how does it work? From the motor, we are having a control signal, that is to which the motor should be in this within this limit, their motor should operate. It should run from 500 to 1500 RPM. 500, it should run in 500 RPM for first 5 minutes. Second 5 minutes it should run in 1000 RPM. Then third 5 minutes it should run in 100 RPM. So we are fixing the control thing, which is to be defined thing, that is called as a set point. That is given to the comparator. This we are fixing it. The second thing is from the motor, the speed of the motor is sensed with the help of the gearbox and it is given to the tacho generator. The position sensor is nothing but tacho generator. And this is given to the comparator. The comparator compares the set point value and the measured value. So if it compares, your error will be calculated. From this error, you are giving to the amplifier which generates the output which is to be varied. In motor, the output varied is the supply voltage. So we are varying that and we are controlling the speed of the motor. Once the speed is achieved, then your error will be nullified, error will be of 0. So there will be no change in the supply voltage. If it is not 0, then your error amplifier plays. Inside the error amplifier, what should be done? It is of two types. Armature control. For controlling the voltage, supply voltage to the motor, we will perform armature control and field control. So the DC servo motor is classified into armature control DC servo motor, field control DC servo motor, or DC series control motor, servo motor. So in the armature control motor, what happens is that there will be a separately excited DC motor. We will consider a DC series motor. This is field control. This is the normal DC shunt motor I am taking, but in this, for controlling the supply voltage, we need to add a variable resistor in the circuit. That is rheostat we will be adding. So this is a DC motor, so will be a positive and negative supply. So for armature control, what happens is that you will keep the field rheostat as a constant. Your supply, the field voltage will be kept constant, and you will vary the armature voltage by varying this resistance. But if it is in field control, what happens is that you will fix the armature as constant, armature voltage and current as constant, and you will vary the field current. And you will say, because of varying this current, what happens is that your field flux is directly proportional to current in the armature. So this will have the effect on motor, and your armature current is controlled directly with the help of this rheostat. So your voltage will be, so V equal to IaRa minus Eb. So with the help of this, your motor voltage can be controlled. Your supply you are giving to the motor voltage can be controlled. This is how your DC servo motor works. The next is the AC servo motor. In the AC servo motor, we can say this also AC series motor. The same thing, your stator part will be there, your winding on the stator will be there, your rotor will be there, and bearing, which is to be for the mechanical support, you are having bearing and shaft to rotate the load. And the same thing, your encoder cable and motor cable will be there. The difference between the single phase induction motor and DC motor from the servo motor is that you will be additionally having an encoder in it. The same thing it will as a DC servo motor, AC servo motor will also control the motor with the help of servo mechanism. So there will be a amplifier circuit will be there. Before that, error detector and error amplifier will be there. So this error amplifier, when error is given, the same thing we are implementing in this. This will give the controlling the phase voltage we are supplying to the stator. So there will be two phases, one is temporary, another one is auxiliary. So fixed phase will be there, and additional phase will be connected to through the amplifier that will control the phase voltage, and according to that your rotor will rotate. From the rotor you can sense the speed, and that will be given to the amplifier. This is how your AC servo motor works. The DC servo motor and AC servo motor is of same concept. The control mechanism is involving in the control of the AC motors and DC motors. Thank you.